Let's continue looking at systems of equations. This time we'll be focusing on the elimination method, which is different from the substitution method. With the elimination method, you want the same or opposite coefficients on one of the variables, so that way you can add or subtract the equations entirely to get rid of or to eliminate, to subtract out one of the variables. As an example, let's take a look at number 1. Let's label our equations. This will be equation A here, and we'll call this B. Well, I notice that both A and B have 3x, a coefficient of 3 on x. If they have the same coefficient, if this is positive 3, then you can go ahead and you can subtract these equations. So that way, the x's will subtract out. You're left with 2y minus negative 4y, that'll be 6y, is equal to 12 minus negative 6 is going to be 18. Now divide both sides by 6 to solve for y. So we find y is equal to 18 divided by 6 is 3. Once you solve for one of the variables, just like substitution, go back and plug it into one of these equations. So it doesn't matter which one. Let's do A just because everything there is positive. So we'll rewrite A here. This is 3x plus 2y equals 12. I now know that y is 3, so this will be 3x plus 2 times y is 3. This is equal to 12. So 3x plus 6 is equal to 12. Solving for x here, so we'll subtract 6. $3x is equal to 6, and then finally divide both sides by 3. So x is equal to 6 divided by 3 is 2. So just like with substitution, once we solve for x and y, this tells us where these lines would intersect if we were to graph them. They intersect at the point 2, 3. Let's do another one. Okay, in this one, I've got negative 2x plus y equals 9, and 4x plus 3y equals 7. Now, here's where this differs from the first one. In the first one, I had 3x for both, so I can just go ahead and subtract them. But in this case, I don't have that. I've got negative 2x here, I've got 4x for the second one, I've got a single y here, I've got 3y for the second one, so they don't match. What I can do, though, is I can multiply one of the equations, all things in that equation, by some number to see if I can get them to match. Let's first label this A and this B. If I were to multiply A by 2, let's do that over here, 2A. 2A means multiply everything by 2. That would be negative 4, not 2. Negative 4x plus 2y is equal to 18. And B will stay the same. So B is still 4x plus 3y. This is equal to 7. Now they're exact opposites. If they're the same sign, subtract. If they're opposites, add. So I'm going to add these together. Negative 4x plus positive 4x. That'll go to 0. Then 2y plus 3y. This will make 5y here. is equal to 18 plus 7 is 25. Divide both sides by 5. And you'll find that y is equal to 5. Then take this y equals 5, plug it into any of the equations. Let's do the bottom one, since everything's positive there. Let's see, b is 4x plus 3y is equal to 7. But since y equals 5, this will now read 4x plus 3 times 5. This is equal to 7. 4x plus 15 is equal to 7. And now I'll subtract 15 from both sides. (4x), this is equal to negative 8. And finally, divide both sides by 4. So we've got x is equal to negative 2. All right, let's go to the third example. In this example, I've got 2x plus 3y equals negative 1, and 3x minus 5y equals 27. What's different about this problem than the first two? In the first one, we had coefficients that matched exactly already, so we could just go ahead and add or subtract. In the second one, we had ones where we could just multiply one of the equations so that the coefficient on one of the variables matched the other equation. Here, though, I can't do that. There's nothing I can multiply 2 by, and no integer I can multiply 2 by to get 3, and same thing for 3y to get to 5y. So what I'm going to have to do instead is multiply each equation by the other's coefficient, depending on which coefficient I want to eliminate. So if I want to get rid of the x's, for example, let's label these first. This is a and b. I'm going to multiply a by 3, since the coefficient on b for x is 3. So I need 3a here. And I'm also going to multiply b by 2, since the coefficient on x for a is 2. So 3a means everything in a multiplied by 3 is 6x plus 9y equals negative 3. 2b means everything in b multiplied by 2. So this is 6x minus 10y, and this is equal to 54. Now the coefficients on the x match. They're the exact same. So I can go ahead and subtract these equations. (9y minus negative 10y), subtracting a negative, that'll be 19y. This is equal to negative 3 minus 54 is negative 57. Divide both sides by 19. Y is equal to negative 57 divided by 19 is negative 3. All right, now for the x's, pick one of these equations and plug in y equals negative 3. So let's do a. This is 2x plus 3y equals negative 1. And we'll plug in y is negative 3. So this will be 2x plus 3 times negative 3. This is equal to negative 1. So 2x minus 9 is equal to negative 1. Add 9 to both sides. (2x) is equal to 8. And dividing by 2, we've got x equals 4. Some people will find that for some problems, substitution is easier and that elimination is easier for others. As you do more of these problems, you'll discover for yourself kind of patterns and ways to identify which ones might be faster or more efficient for you to go one way or the other.